Hello, welcome back to another of my new video. In today's video, I'll be showing you a really interesting oil lamp called the Famos 120 candle power lamp. This lamp works really similar to an Aladdin that uses a mantle, but right now I don't have any mantle for this lamp to work correctly because the mantle is not in production for many years. Inside the lamp, you can see is based on the center draft principle. Here's an air hole, goes all the way to the bottom of the lamp, which you can also see air vent at the bottom, which allows the air to draw in the center metallic tube. And this is an outer tube. Combined together is called a wick tube. Inside it also have a really high quality wick carrier, which allows the really easy adjustment of wick coming up and down. The wick is soaked in paraffin oil, or known as kerosene oil in other parts of the world. And to showing you, it's based first on argon's principle. Also, the next is based on air mixing principle with the air mixing chamber here you can see on the base of the lamp. The air mixing actually allows the airs to mix really good in a really good ratio that allows to achieve a blue flame. But before I do that, we'll have a look on how does the flame work. So before I go further, here I got myself a propane torch. Here you can see it's got yourself an air vent. What would happen if we close the air vent completely? We can find out. If we get it closed completely, open the air and light it. You see, it's a luminous yellow flame. But what would happen if we allowed air to mix in? So here we can see we just need to close the valve up so air can mix into the chamber. Here, air is allowed to mix with the venturi. So now open up again, we got a different result, really different. Now it's too much air being allowed to mix in. Now it's a perfect Bunsen blue flame. If we can see here, you got the downward cone and upwards non-luminous flame, glows incredibly dimly. We can achieve this the same way with the oil lamp, by allowing a proper mixture of air and fuel to achieve complete combustion. First, raise the wicks just slightly. Before I need to do that, we need one last thing. This is called a air mixer, or flame spreader in other parts of the oil lamp is known as. Flame spreader in like the old vintage lamps allows the flame to be spread out as it produces jets of air outward, blowing away the flame. But this acts more like an air mixer. Get it just right. Raise the wick just slightly and lit the lamp. You can see initially it's a yellow flame. If we raise the wick up further, we can see a sooty yellow flame. Just lower down. What would happen now is we bring up the lamp itself. Watch the flame changes its color. We need to find the correct slots to fix the chimney gallery down. Yep, now it's in. Still have a bit more yellow because there is not enough draft yet. So what we do, we crank it up. Completely becomes non-luminous at all. It glows really hot. You can see the metal wire starts getting scorching heat, meaning the flame reaches a really high temperature. Also, the lamp produces a ton of heat, which is really useful if you want to use it as a little room heater, a paraffin heater. Output 800 to 1 kilowatt of power depending on how high you put up the flame spreader. This flame spreader actually you can put into a certain position. It has one resonance point because the chimney has a set special length. After you hit that length, you go the wick just slightly up, you can achieve the second really highest combustion blue flame. Not on this wick, this flame spreader settings. You have to raise it just a bit higher, tad bit higher, and you can get that. When you reach on that really high maximum setting, its outputs about like basically 1200 watts of power. You can work out the power actually by first measure the initial weight of this entire lamp, let it run for 1 or 2 hours, and wait the second time the weight change of paraffin in the tank. So if you can get that measurement, measure the amount of fuel being used, you can calculate out how much heat is actually being produced. Because we're using a really high combustion here, a really complete combustion with a blue flame, zero smell, meaning all the fuel is being burned completely. So with that one, say we can actually use the ideal calculations to work out the amount of energy being released per gram of paraffin, then give us a conclusion about 1200 watts for maximum on that really high setting. If you go a tad bit higher than that setting, you will actually start producing soot. For this setting, you can actually produce soot much more easily. If we just keep on rising, you can see the flame is about out of its slot, and now what's happened here is in resonance. And if we go a bit higher, the flame might extinguish itself, because meaning the flame is no longer licking the wick anymore. You want to go below that. Oh, now it's really hot. You can see the wire actually deformed because of the extreme heat. So if you just go here, actually it's become a much more manageable heat, and it heats up a little room really well. By the way, if you want to use this thing indoor, you have to make sure you have a good ventilation, or else you might have carbon monoxide poisoning. So it's also handy to have a carbon monoxide alarm in your room if you're gonna use it indoor, as well as a smoke alarm, just in case if somebody managed to knock it over. Yeah, keep away from small children and pets. If this thing get knocked over, it will be an immediate fire, because the chimney right now is scorching hot, and the wick actually depends on the situations. Sometimes when you knock it over, what will happen is that it will immediately disturb the draft. This lamp is really sensitive to draft. If the draft is gone, the flame is gone, because the oxygen went missing. But if the oxygen did not went missing, and the fuel travel from the wick tube all the way down here and touches the glass, the fuel will be immediately vaporized. Since kerosene have a flash point about 60 degrees Celsius, this chimney right now is probably 100 degrees. Top here will be about like probably 300 degrees Celsius for at minimum. About this section, really hot. About this section is slightly cooler, but above that you probably want to keep about 80 centimeters of clearance to the top of your ceiling, just in case if you caught your ceiling on fire. It will be really handy if you also have a, like what you call a smoke bell, or I would also call it as a heat bell. Actually disturb the column of hot air. There's a really hot column of air just below that. Well, air scorching. Really hot column of air up just above that. This hot column of air is traveling in such a laminar flow. You can hear another really fascinating thing. With nearly all sorts of blue flame heaters, you can hear the like hissing sound, because of the venturi nozzle generated also disturb the draft of the flame. It actually produces the hiss noise. Is quite significant. This hiss noise is also really noticeable if I get myself something called a Bunsen torch. You can hear, because of the venturi, actually it produces a really complete different characteristic. The flame itself also produces a characteristic sound. If I blow the flame out, you can hear. It still produces sound. The flame also produces sound because of the disturbance of draft. But this flame produces zero sound at all. None of I can hear, because the flame is traveling such a laminar fashions that the flame doesn't really resonate or oscillate at all, being a complete dead silence. The only thing that gives away that the lamp is working is this blue flame. Anyway, hope you like it, and I shall see you in another of my new videos.